Nicholas Kopsiaftis, 2/21/2020. This is Unit 2 case connection. I chose problems 3 and 4, and I'm going to present problem number 4 first. So the child is presenting with hypoglycemia, so obviously it indicates low blood glucose levels. What happens is clinician administers epinephrine, and the child shows no increase in blood glucose, but there is an increase in blood lactate. There's a physical exam that shows an enlarged liver. Blood glucose levels normalize after breastfeeding, but they are not maintained during fasting. So in epinephrine administration should cause the liver to convert glycogen, store glycogen to glucose, which would raise blood glucose levels, but this does not occur. Glucose levels stay stagnant and lactate goes up, and that's it. So child isn't really showing an inability to metabolize lactose from breast milk after breastfeeding. Galactosemia probably not causing the symptoms. If it were galactosemia, the child would show an inability to break down the galactose from the breast milk, but the child's doing just fine metabolizing breast milk. So it really just seems that the glycogen levels are not being maintained. So the child also doesn't really show the possibility of a hereditary issue, specifically the hereditary fructose intolerance. The symptoms are presenting a couple months after birth, so any sort of hereditary issue probably would have shown up a lot earlier than that. Child's also not showing any anemia, so it kind of eliminates the possibility of a glucose 6-phosphate dehydrogenase deficiency. So with all that being said, and the elimination of the other possibilities, it seems that the issue is related to stored glycogen and the inability of using stored glycogen as an energy source, which is why this is occurring in the fasting state. So symptoms point to GSD overall. Epinephrine would raise the glucose levels from glycogen storage if the child was able to store glycogen as a reserve. Not the case. So epinephrine raises the lactate levels, but not glucose. So that means that the child's not storing glycogen properly. So that leads to the answer of GSD1 being the issue at hand, also known as von Gerdt disease. Typically presents a couple months after birth, consistent with the findings. Signs of hypoglycemia and liver swelling, all consistent with the child's symptoms. So it would make sense that the child is unable to store glucose, or glycogen rather. Okay. And the next one I did was question 3. So in question 3, there's a test done, and it shows that a patient has very low insulin levels both before a glucose load and after. Suggests that patient's not producing enough insulin, obviously going to be affecting their health and wellness, which is why their patient rather, is so tired and is suffering. Insulin deficiencies, such as this one, where there's just not enough insulin being produced, is referred to as diabetes 2. Body's just not producing enough insulin. So that would obviously affect the patient's fasted blood glucose levels, because a lack of insulin would increase blood glucose levels due to the cell's inability to take up glucose from the bloodstream. So adipose and skeletal muscle would be affected due to the need of insulin for GLUT4 activation. A couple of enzymes that might be active in the case of low insulin levels would probably be glycogen phosphatase and fructose 2,6-biphosphatase, also known as FBP2. So in glycogen synthesis, the regulatory enzymes are glycogen synthase and glycogen phosphatase. In the presence of insulin, glycogen synthase would get dephosphorylated and become active through protein phosphatase 1, and that would increase glycogenesis. But because there's no insulin, what insulin does is it increases protein phosphatase 1 surface area, and that stimulates the synthesis of glycogen. Without any insulin, glycogen phosphatase and glycogen synthase get phosphorylated rather than dephosphorylated, and a dephosphorylated glycogen phosphatase becomes active and therefore results in a decrease in glycogenesis. So in gluconeogenesis, fructose 1,6 biphosphate is converted to fructose 6 phosphate using FBP2. In a fasted state where insulin levels are low, the enzyme expresses phosphatase activity, which dephosphorylates glucose 6 phosphate in order to free glucose from the liver. With low insulin levels, FBP2 becomes active as a phosphatase and inactive as a kinase, which is kind of what's going on here. So low insulin increases the activity of both FBP2 and of glycogen phosphatase. And those are the answers. It's a little short, the video, but hopefully that was okay.